I'm John Fasella. I'm a former president of the Radio Club, and we have the pleasure of interviewing tonight Gordon Beattie, who's the Senior Principal Research Scientist at VIAVI Solutions. Well, folks, it's 9 o'clock. We're going to start promptly now. Hopefully, most have joined us. My name is John Fasella. I'm the former president of RCA. Tonight, we're going to welcome Gordon Beattie, who is with VIAVI, and most of you know Barney Scholl, who's RCA's VP and counsel. And Barney is going to be the traffic cop for the audience questions at the second 30 minutes. So those of you who have been here before know that the drill is basically I give an infomercial, and then we get into 30 minutes of prepared questions that I have for Gordon, and then another infomercial, and then it's whatever the audience comes up with. This is going to be a fun interview and rather different from some of the others we've done. Gordon and VIAVI are involved with test equipment. That's not an area that we particularly explored before. We might run a little bit over because Gordon has a number of interesting areas to explore with us. So without further ado, Gordon, why don't you give us an intro to yourself, please?
John, Barney, Amy, and the rest of the Radio Club of America, I want to thank you for this opportunity. This is quite an honor, to be honest. I guess my background is I'm a senior research scientist in the wireless area for VIAVI Solutions. I work in the CTO, so I get to work across all the business units of the company, which provides a really exciting opportunity every day. Every day is an adventure, everything from positioning, navigation, and timing to optical systems to our mainstay cellular type work, and of course land mobile radio and green radios and military navigation systems. So it's amazing. I mean, every day is an adventure for me, and looking for synergies across those things. So I guess as a matter of background, how did I get into this? Well, I'm a ham radio operator, and I've been blessed with a decent education, but I have no advanced degree at all. In fact, I have no degree at all, and that's always caused a bit of puzzlement. But because of my amateur radio experience and also my interest in propagation and antennas and VHF, UHF, and microwave, that kind of sparked a really useful set of skills as we ended the 20th century and got into the 21st century. I mean, like a lot of us, I got busy doing things like listening on AM radios for faraway stations. And then I got to use my grandmother's Zenith receiver in a rural New York environment. And I heard stations from all over the world. And that's opened up shortwave radio. I did that for about 10 years until I got my ham license in high school. I can't tell you the number of times I got in trouble for having the small format electronics, magazines of the time inside of a textbook. I got, all through junior high school and high school, I got zapped for that more than I care to think about. Yeah, it's all good. But I ended up interested in packet radio along the way, courtesy of some introduction into Data Communications magazine. I actually dated the daughter of Harry Karp, the founding publisher of Data Communications magazine. And Harry, God rest his soul, put me on the comp list as a young student, and that kind of changed my perspective. I learned about things like extended super frame and Aloha networks and any number of things that were kind of interesting along the way. And the OSI stack versus the IETF stack, the TCP/IP stack, that we all know. So I kind of got interested in data communications too. So long story short is I ended up very active in packet radio, published a few things, and while I was working as a X25 programmer at uh, manufacturers Hanover Trust in New York, I was asked to come out and give a couple of talks at Bell Labs in Homedale to explain how we did packet radio. And basically, it was LAP-D. So, if you remember that protocol, it was a link level protocol that was designed to be good for dial-up users over async modems. And we were basically doing something similar to that with packet radio, except we embedded our call signs in there. And I wrote a couple of things in a couple of conference proceedings, and that got some attention. So hence the talks. And years later, I was working as a consultant at Belcor and didn't want to be at Belcor. I ended up, someone said to me, "Do you know anybody at Bell Labs?" And I said, "I knew a lot of people at Bell Labs." So next thing you know, I had some references and I had a job opportunity, and I went there in 1987 as a consultant. And in 2020, I left, having been a member of technical staff and various other titles as they reshaped the company over a period of years. So it's a blessed career opportunity, but one of those things was a lot of opportunities to do some innovation and creation of intellectual property that we could actually put to work. We had gone from the we hope to put something useful together that's good 20, 30 years from now, kind of Bell Labs, ATT Labs, to what can we do now or over the next 5 years and monetize it now. So a lot of my intellectual property is very practical, and includes a lot of guys who have union cards, to be honest, and that, or at least operations pedigrees. And so and I got dirty in the field because I had a hands-on capability as well as the analytical capability, as well as the ability to write. And I thank, the good Lord, my parents, and, the Jesuits for educating me to, learn how to write and present myself halfway decently. So it's
Well, that's great.
pretty lucky.
So you said something very interesting that I'd like to explore almost right away.
Sure.
You're a senior principal research scientist. You have 167 patents and counting, yet you don't have a university degree. And you're working in a CTO office. I mean, that's really unusual. Could you elaborate a little bit on specifically how you managed to do this? Because I'm sure there's some people in the audience that either don't have degrees or don't have the degree they wish they had and are thinking, gee, how can I leverage that in my career?
Yeah, at some level, and this is, and my colleagues at the labs were very good about this, but also here at VIAVI, they're extraordinary. I mean, all my close colleagues in my organization have PhDs, and I'm the only one who doesn't. And so, it's truly an honor to be in their midst every day, not to mention the rest of the VIAVI technical community and even the marketing and sales community. I mean, these are outstanding people. I mean, let's straight up. I mean, it's about what you can deliver and what you're willing to go learn. I mean, if you're willing to educate yourself and get up to speed on something in reaction to a need or a problem, and you can adapt. At military academies, they always have that thing where they're reading the newspaper while they're brushing their teeth. And while I didn't go to a military academy, I did go to a junior ROTC high school. We were required to, account for things. There were a bunch of facts about our school that you had to know. And it was about being a quick study, being able to communicate effectively, very quickly, and also be willing to do the hard analytical work that goes with it. And that sometimes means going into the field and finding where the data comes from. Where are the problems? Who has experienced the problem? How are they experiencing the problems? And listening to the end user and or your colleagues as to what struggles they have, and then try to work something out that you can that can solve their needs. So being a ham, you have that kind of MacGyver mentality. I think whether or not we're doing radio or not, we tend to be problem solvers. In fact, even when people don't want their problem solved, we tend to want to solve their problem for them, whether they like it or not. My wife reminds me of that every summer. She said, you don't have to solve the problem. Sure, I do. But anyway, it's in the DNA. But I think that's the key is to have it just a natural curiosity and a drive and a humility just to get dirty with the data, with the techniques, whatever it is. I mean, I can do copper splicing. I can't do fiber splicing. I've never had the chance to do that very well, or formally, but I've done copper splicing, and I've put up towers and all manner of things. So uh, it just kind of blends into the landscape of what goes into you in order to be able to function at a high level with great colleagues who have who are trained differently than you.
Hmm.
I think that.
That's interesting. So let's explore one of the things that you've been working on that intrigued me a bit. Use of 5G technologies on the battlefield. Can you talk about the design principles for networks and devices for warfighters? And while you're talking, I'm going to show one of the slides that you shared with me so that others can see that at the same time. That'll be slide 21.
Okay, so I mean, there are a lot of really, key, you know, key elements to that. A warfighter really wants to have uh, simplicity. They want to be able to turn the unit on and be assured that they're going to get comms. I mean, that's key. Um, what they don't want is a lot of complexity, um, unless there's a lot of value added to that complexity, and they can work through it and essentially engage in muscle memory in order to work through it. But even then, it distracts you from other tasks that might be related to accomplishing the mission or staying alive. Um, the other thing is, you need to be able to use comms to get resources, to understand the landscape, to understand the threats, um, and you also have to be able to. And we don't do this as well in these 5G networks, but one of the things we might want to do in the future is to capture the communications flow and overlay that with performance data, by the second, um, so that we can see if there were communications issues, what was the nature of the communications issue that caused a uh, a, a bump in the operations flow of a mission. Um, the other thing is, you know, if you're going to create a lot of unnecessary overhead and it's not a lot of utility, that equipment is going to get left on the shelf next time they go out on a mission. Um, and the last thing, and this is almost a big concern with 5G, is 5G doesn't shut up by its necessity. Its design is to be very active on the air. So ComSec, or communication security, depends on low probability of detection and low probability of intercept. So 5G either has to hide in plain sight or be in an area where you dominate the landscape and are not subject to interdiction of your comms by an opposing force. So it's got a lot of challenges, to be honest. And we'll talk about it later, but there's a lot of single points of failure related to its resilience too. We'll talk about that.
Right. Well, and we'll talk about that in a moment. But to your point about a lot of challenges, uh, because I must admit I have my own concerns about using 5G on the battlefield. DoD's Director of Future G and 5G, Thomas Rondo, has mentioned concerns about using this complicated network technology on the battlefield. And he said things like, will the network be resilient enough? Will it be able to deal with a sophisticated enemy who will try to spoof or jam it? Is it going in the opposite direction of the KISS principle? Keep it simple, stupid. So I'm going to let you comment on that while I bring up two more slides that you showed to me recently. Go ahead, Gordon.
Sure. So There are a couple of things. So there's a lot of single points of failure. In a modern wireless system, and so and we all have experienced this. You attach your device on a network, you make your connection. The connection somehow during that period fails. It times out with a 20-odd second timer, and then it has to be reestablished, and the applications have to resync and all that stuff. In a battlefield, you don't have that luxury. So if I blow away your cell site, and I'm not going peer to peer, or through a resilient mesh, then I have this very hierarchical network. I mean, so what you're going to need is multiple cores, multiple RAN, radio access networks, and multiple radio interfaces. Basically, think about these as base stations or mobile base stations or peers, and whether they're mesh enabled or whether they're hierarchical, you're going to need to have the ability to be multi-connected so that you have that resilience. I mean, Mr. Rondo's concerns are very real. Now, in a base environment, there are ways to build resilience into that. In a expeditionary environment, it's a little more complicated, but it can be accomplished as well. If you're on the move, it's real. Let's say as a squad or as a convoy or some moving force, you've got all kinds of issues, of connectivity and maintenance of connectivity, based on jamming, based on kinetic interdiction. Basically someone blew away the node you're trying to talk to. Yeah, there you go. So I mean, and the battlefield is very different than a consumer or even a normal enterprise environment, in that you're on the ground, you're talking to peers in the air above you. Your base stations may be NTNs or high altitude platforms. Non-terrestrial networks are high altitude platforms. They could be fixed parts of the infrastructure. They could be combinations of those things. They could be combinations of those things, both seamlessly inserted and also redundantly provided. So there's a lot of moving parts here, and they themselves, those components, need to be part of an ecosystem. So it can get very, very dicey. I mean, if you're in your brigade CP, it's not a big deal. If you're in division CP, again, not a big deal. I mean, within that context. But when you're out in the field, it becomes very messy. But even if you're on a flight line, you can't afford to have, let's say one of your towers gets blown up, you still want your flight operations to be maintained. So you need to have another site that is providing that service. And in 5G, there's a notion of cell-free that's kind of evolving, where you're not tied to a physical site, you're tied to a collection of sites. So if one part disappears, you still have connectivity. Now, the military requirements for that it's not quite up to snuff for that. But with some tweaks, the DoD's requirements, could take the 3GPP Open RAN kind of strategy and architecture and adapt it with some specific extensions and parameterizations that would be tailored to the needs of the military in both a base, a expeditionary, and also a mobile context.
Okay, that's fair enough. I do see an interesting metaphor, and I think some of our audience will as well, because a lot of us are familiar with public safety land mobile radio, and
Yep.
Land mobile radio has embraced siloed autonomous networks with multiple layers of fallback to ensure resiliency. And these concepts were developed decades ago, quite frankly. When FirstNet came along, it created a nationwide wideband network which all agencies could share. So in a sense, we're now aggregating lots of public safety on one network. My question to you would be, do we have enough fallback capability for warfighter communications to survive if we move the military to 5G? And while you're answering that, I'm going to move to another slide, which you suggested.
Well, I think the short answer is probably no, because you never have enough comms, right? You never have enough resiliency, but you have the resilience that you're dealt. You fight with with the tools you have, with the weapons you have. So in a classic hierarchical cellular network, you can see that there's a number of single points of failure going between the user and the base station, and then up through the RAN and into the core, into the application space, and even to the timing space. We haven't talked much about that, but if someone comes in and spoofs your timing and your geolocation, everything gets out of whack and nothing talks. There's some really pernicious ways to undermine a network these days by fooling with the timing. Um, uh, but the you mentioned FirstNet. FirstNet is very good at, and it was originally, as we've discussed before, meant as a data overlay on land mobile radio, but it's now morphed to actually be the dispatch comm platform as well for voice. And it's a lot of infrastructure. It's several orders of magnitude more complex than most even complex trunking land mobile radio systems. Plus, this infrastructure that you see in this architecture doesn't run unless it all runs. In other words, if I have a base station in a multi-repeater situation on land mobile radio, each repeater will default to standalone operation, even if its network connectivity gets blown away. So for some envelope around that site, you'll have communications, on one or more talk groups, depending on how the system is set up for each base station, or if you will, each repeater site. Not so with cellular. So there's some growth opportunities to do there, but FirstNet offers a huge advantage in that it can add a data overlay, high bandwidth data overlay, and that's important too. And I have high hopes for whatever happens to the 4.9 gig band. If it ends up with in the hands of the FirstNet authorities, I suspect that's what the FCC wants it to do. And people are challenging that, and it will follow whatever happens in the marketplace. But as a practical matter, there's some opportunities to do some clever things for the public safety operator there as well. And I'm just going to take this one step further. You need to have the applications be resilient as well. So peer-to-peer applications. So in an ideal world, I would have some form of peer-to-peer communications, even if it's a lower bandwidth among peers, or limited reach. And then if I can get one of those peers to have connectivity as an uplink to the main network, whether that's via satellite, whether a remote cell site or whatever, all that's good. But I do need some sort of peer-to-peer. We talked about side linking as one possible solution, but it's a little clumsy, and there's a side link relay which allows some multi-hop nature of going through peers to talk to each other. I think
What
that's
is
fine.
side link? Can you define that?
Yeah, side link was originally defined for the automotive industry, but basically it was designed so that you'd have a device talking to another device that actually would talk to the cellular network, but using the uplink, using the downlink band. So, as both a shared channel, to provide peer-to-peer connectivity. And that's fine. But it again has limitations. And also think about what happens when you have a cellular device. In fact, my colleagues at VIAVI are probably cringing right now. But here's a land mobile radio, and here's a cell phone. This is 600 milliwatts. And if it's on band 14 and it's high power, it might be 1.3 watts. But its bandwidth is typically, a meg and a half, or 5 megs, or 10 megs, or 15 or 20 megs wide. Whereas this guy is, 12 and a half kilohertz wide, So, and oh, by the way, at 2, 4, or 5, and in the case of a mobile, maybe 50 watts or 100 watts, base station. Um, so clearly there's a rate versus reach trade-off there, right? You don't have the bandwidth to do a lot of high bandwidth stuff, but you can reach out and touch someone, and getting something is better than nothing. And so, you have to look at your operational picture and your risk factors and decide what makes best sense for you for your mission profile. I think that's the key. And I would argue that, pushing the applications closer to the end user, the network edge. In fact, I was reading an article this morning about AI's sweet spot is I think it was on RCR Wireless. I saw it this morning. Um, that AI's sweet spot is at the network edge. Absolutely. Now the question is, the network edge an infrastructure element, or is it right here, or is it the two operating in concert? Or maybe a set of these with a set of those operating in concert as some sort of, should we say, computational cyborg. I mean, you don't know. I mean, all that will emerge over time. The but I can see in the future, an extension of what we do now. I mean, in our homes, we use Wi-Fi to make cell calls. Now, how do we do that? We're not really on the cellular network. We're not using the RAN at all, generally. What we're doing is we're going over Wi-Fi in our home or our business. We're in a public space. We're then getting some form of internet backhaul to the network operator's core. We're registering there, and and we're be able to initiate calls. So it's cell over Wi-Fi. There's some problems with that. I can go from my Wi-Fi to the public network. I can't come back onto the Wi-Fi because of security concerns and tunnel terminations and things like that. But that's fine. I mean, we can work that out in the future. But what I am saying is that we already have these over-the-top kind of conjoined non-cellular users talking cellular. If you think about it, I mean, I can make a cellular call from my PC if I really want to. I mean, so, we have to start thinking more flexibly and architecturally more broad. So maybe the air interface isn't what we normally think of as the normal RAN air interface for between a UE, a user element, and an RU or radio unit, the remote radio head. Maybe in the future, it'll be a mesh network that will get us to one or more key points that have that connectivity that will get us either into the RAN or into the core. I mean, those architectural decisions have to be worked out in the future. But that does beg the question of resilient applications. So you can't have the call drop in that case. If you're switching connectivity modes, you still have to have connectivity no matter which mode of network you're using at the moment. Right now, as I say, when we go from the public network to Wi-Fi, it drops the call. But companies like Apple have streamlined that a little bit, and sometimes their calls stay up because you're really talking to the Apple core, and and they maintain some level of connectivity or reestablish it pretty quickly so that it's fairly transparent to the end user.
So I want to explore something a little different. You've done some work on predictive algorithms to find faults in communications networks, and possibly some of that is using artificial intelligence. And your current employer is a manufacturer of test equipment. So can you give us a little bit of insight into how these predictive algorithms might work, and is that being incorporated in modern test equipment today?
It is, and there's a whole lot more to come. So, I mean, if you look at some of our Nitro Geo products, the way they examine elements on the cellular network, they can make some really good geolocation estimates as to where things are, based on some predictive algorithms. We also have a thing called a RAN scenario generator, um, to basically drive, um, to drive all kinds of use cases, but also, um, to kind of, it's based on what we see in the live network, or what we've seen in live networks. Um, One of my favorite predictive maintenance stories, it goes back to my AT&T days, where we had a back in the old days, the minor alarms were discarded because they weren't actionable. I mean, so you discarded them, and so for good reason they were tossed. But I started looking at them anyway, and I found one. I won't go into the details, but I found one that basically told us that we had a power supply that was pending failure. There was no question about it. And people say, well, we don't look at that. I said, well, you need to look at it. And so long story short is I started looking at it. And once we had a country isolation or two, based on, that kind of got everybody's attention. It's like, oh, maybe Gordon's got a point here, and, people know what they know because they live within their context of operations in their world. And so it would be unfair to evaluate their performance any other way. But the bottom line is, when they got hit in the head a couple of times, they said, hey, tell us about this. And we did a trial, and we proved out the point. And we were able to say that, if there was one little glitch on a power supply that wasn't actively being manhandled in and out of a nest, that was a problem. It was telling you that you had a pending doom. And what the pending doom in this case was a fan that had stopped working, therefore the power supply was overheating, and therefore would create these glitches. So, the trick is to literally read the data. So, in AI, if you think about it, you really need to think about, understanding what's physically happening in the network, whether it's in an RF space, whether it's in a power space, whether it's in a military operational space. They're actors, and they're and things get acted upon. And you look at what happens to an actor when they act on something. Do they get a negative reaction? Do they get a positive reaction? Do they get the reaction they expect? What's the fallout from it? You look at all those subtle things, and you aggregate them over time, and across network layers, in our case, or operational layers in the case of a military network. Because you think about it, many operational failures are due to cascading underlying problems, So whether it's a maintenance problem, whether it's a design problem, whether it was a failure to communicate, whatever, you have to look at things in a multidimensional way. So predictive maintenance is a cross-domain game in most cases. And so if you didn't like simultaneous equations in school, this is not for you. And I loved them, in case you're wondering. I'd say poor math student. I love simultaneous equation. That was give me more. That was fine.
So where is test equipment going in the future? I mean, besides just saying it's going to be more dependent on AI, what does that all really mean? Because in my view, AI is something that has learned from the past and then tries to apply that to the future. So what else is there besides AI?
Okay, so real time adaptations to the operational network and or operational situation, and changing parameterization, maybe even configuration to meet those needs is one. But in test equipment specifically, I would think over time you're going to see we do auto tune or auto test and then auto align. So if we start baselining where things are testing to be, and even if we don't have auto alignment enabled for a customer because that's what they didn't want to have it, we can start seeing the progression of various parameters of their device that are nominally acceptable, but there'll be a progression toward the dysfunctional edge of performance. In a lot of, let's say P25 and other timing dependent digital narrowband modes that, in the mobile radio, the farther you're away from the site, the more timing becomes more critical. Um, so a user who's in the dispatch, parking lot has no trouble. But if he's 25 miles away, the signal sounds like heck. And it's not because he doesn't have enough RF. It's he might have a timing problem. So if you just benchmark the progression of a succession of radio tests, you'll be able to predict when that device will come out of spec and totally and become unusable, at that 25-mile mark or whatever.
And is that benchmarking done with AI, or is that done with human operators keeping spreadsheets or data, large databases of information that they're analyzing?
Well, okay, and in order, let me also just add one more thing. So if I get a set of radio, I'm going to answer that in a second. But if I also have auto align, if I look at the amount of deltas that I have to apply to various parameters of a unit in order to bring it back into calibration, and I record that. So now I might have 50, I might even have 500 parameters. How do I know what's important to go look at? So I'm going to use AI and machine learning to tell me which parameters are the ones that are causing the various kinds of discord that the users are experiencing, and actively focus management's attention on resolving those things. But also, I have the opportunity to provide a recall of that unit before it becomes out of spec, and I can get it tweaked up and fixed or replaced, as the case may be, for the user, so that they're never at risk. So, the trick is when you're looking at a sea of data, John, how do you know what's important? And
Okay.
if I'm a design engineer or I'm the manufacturer who's going to provide warranty, now, and I'm a subcontractor who's got to provide warranty, I need to know what's moving, and so either fix it so that in my next version of the product I don't have that problem. So I might be even changing the supply chain for subsequent versions of that product or new products down the road. So this is a very deep and sweeping set of things, because number one, you don't know what data to look at. I mean, yeah, an educated person will have a rough idea, but you'd be surprised when you're talking about down to the component level, what goes sideways. You didn't know that, the quality of an ingredient that went into a resistor pack, decided to, be less than what it should be. And 3 years out, it's starting to be wonky, I mean, who knew? I mean, it happens.
Let me change this slightly. This will be
Sure.
my last question. Um,
Sure.
so I noticed in your background that you have been a Boy Scout leader, and you've also assisted sheriff's departments in New Jersey and Florida with public safety communications. Why did you do these things?
It's an interesting question. So I guess my initial response is I had a choice. I guess we all do, but so much has been given to me, opportunities that I couldn't possibly ask for. So, I mean, in my personal opinion, I mean, these are gifts from God, and but the people around me who've nurtured me throughout my 66 years of life so far, have given me much. So I naturally want to share it back and or use it for good purpose. It our Boy Scout troop was kind of amazing in that we were a pretty gnarly troop. I was never a Boy Scout, by the way, which it adds more excitement to this adventure. So my wife signed me up for Cub Scouts with my oldest son, and the other son, who was 26 months younger at the time. Um, she said, "Well, 3 Fridays a night three Friday nights a month, you're going to go to this Cub Scout meeting. And I knew what that was because I had been a Cub Scout for a year when I was a kid. And you go there, be helpful, and keep the younger one in check. Okay, well, the next year the den meetings were at my house, and the following year I was the Cub committee chairman and the den leader of my second son, and then ended up being a scoutmaster down the road. So we, I basically figured out that kids like adventures. I mean, I know I did as a kid, and so what we did was we went basic back to basics, map and compass and land navigation and knowing how to look at weather, signs of weather when just by looking around you, and all manner of things like that, and becoming more self-reliant. But we also then overlaid a lot of high tech. So boys in my troop had Skywarn weather spotter training, Water Institute, by the way. And ultimately, it was kind of ironic. The BSA required outdoor training for weather if you're doing outdoor activities. That came much later, but they do, it's part of their safety protocols now. Another one is a lot of kids got their ham radio licenses. A few became CERT, community emergency response team members as teenagers, which before there was a teen CERT, which was, thank God for the graciousness of Bergen County Police Department and their Office of Emergency Management. They put my boys through that just fine. But a lot of them ended up with high tech, jobs. A lot of them served in the military. A lot of them served in law enforcement. A lot of EMTs. My oldest son was an EMT for years. So I'll give you a hint. In 2005 or six, I can't remember. 2005, I bought myself a CF29 tough book, Panasonic tough book, and had mapping software on there, and I attached a GPS to it, so the boys could take handheld GPSs and track with waypoints where they had hiked, and then and so they would tell me based on their map skills where they were. Then we'd overlay the waypoints they actually took, and we put that onto the map. In a campsite, I'd break out my CF29. They'd put it up on a topo map. They download it from their GPSs, their waypoints, and they were often surprised how well they did, and often surprised how well they didn't do. But they learned a lot of things, and a lot of them, I have a lot of doctors, lawyers, and engineers, but I also have people who are public safety officials and people doing other kinds of jobs, motorcycle mechanics and all sorts of things. In fact, one of my boys was on Orange County choppers, which was pretty
Wow.
cool. Yeah. So
Well, you're obviously a believer in giving back, and that's
yeah.
very commendable. And I think we all have to think about that. What can we give back? So we're going to change this up in a second. I just want to mention a couple of things. You talked about AT&T and Bell Labs, and for those of you that were in New York City and joined us last month for the Radio Club's annual dinner and also the Tech Symposium, we did two field trips, which were really good. We went to InfoAge, excuse me. We went to the AT&T Museum. We went to the horn antenna at Bell Labs in Hamdal. And then the second day, on Friday morning, we went to NYU's wireless laboratories with Dr. Ted Rappaport. So these are the kinds of wonderful things that if people attend some of our meetings, they'll get to do. And, we had two a day and a half of solid. I mean, we didn't have enough time to see all that we were able to, what was presented us for seeing. And I would encourage people to attend our annual meetings and our tech symposiums, because we're going to do some more interesting stuff next year as well. Okay, Barney, if you're still there, let's get some audience questions. I'm not following it too closely, so hopefully we have some.
Well, no, there haven't been any real honest.
Oh gosh, we wowed them, huh?
I may have to come up with a couple myself, even.
Well, I have a couple of my own, but I want to wait a second and see if anybody wants to respond with questions. because we covered a lot of different areas, and hopefully
Quite a
that
few.
prompted some interest.
I'm trying to read
So,
here
somebody
Yeah.
put something up on the
in the
chat.
chat. Gordon, I loved your life story of how you're exposed to shortwave listening. Jumpstarted your curiosity in fascinating and exciting career.
Well, let's put it this way. I mean, so just as a background, I was the kind of ham who, as a teenager, wanted to get off of HF radio because I had been a shortwave listener for 10 years. I was done. I wanted to do Dick Nadel and, guys like that were my heroes built, doing EME, moon bounce type stuff and, building great arrays. I mean, Carl Scheidler, W2AZL with its 2 meter converter based on a new Vista. It's like that stuff was magical to me as a kid.
I think I built one of those years ago too.
W2AZL converter, yeah.
Yeah. Another question. Gordon, explain what the U.S. military is using regarding 6G. What are other foreign nations using for their military communication systems?
Okay, so there's no 6G per se out there at this time. There's a lot of talk. There are some really nice, and you can look at the literature. I don't want to call out specific vendors, but there are some nice mesh vendors out there, tactical mesh vendors of various types with various levels of bandwidth, everything from LoRa up to some really wide bandwidth stuff that are, tactical comms, both vehicular and backpacks and handhelds, but that are also coupled into a cellular network. How they're each doing it is a bit different, and I wouldn't want to speak to how each one does it because I don't want to get it wrong and besmirch a brand. But there's there's at least 3 or 4 really major ones out there with tactical mesh networks that will actually allow peer-to-peer, but then also access to higher echelon communications, which could include a cellular infrastructure, which may not be local, in its infrastructure. As you may have a remote capability to then look at a G node B or a core that's remote, very much like you have with your cellular over Wi-Fi type scenario today in the consumer market.
I'll throw one of my things I was thinking, Gordon, is I often like to ask people how people should get into your field, but you have such a broad background, variety of fields you've been involved in. Other than amateur radio, which you've talked about, any other suggestions on younger people wanting to get into the, I hate to say wireless or technical field, but any other suggestions of how a younger person should approach it?
Yes. Okay. Number one, do not, and I emphasize this again, do not do what I did, for God's sake. The marketplace is highly intolerant, and I've been just an extraordinarily blessed person, very lucky. I mean, the word unicorn comes to mind. So it's hard to find them these days. Having said that, a couple of things, and this goes back to the AI question. If you use conventional wisdom and you accept conventional wisdom and crowdsource data without understanding the exceptions, you're always going to be predictable and not handle the corner cases. So a lot of the AI has to be geared toward identifying those corner cases, those anomalous things that are beyond what we call good engineering practice, good conventional wisdom, etc. So you have to be willing to go out and explore and tinker. I cannot emphasize tinkering at every level, whether it's in software or hardware, whether it's RF. Get your hands dirty with data, but by experiencing it. Watch. I mean, I remember sitting there for hours. My wife would look at me like I'm a moron, looking at different packet radio connections, going click, click, brap, 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 brap. And she says, how long can you listen to that? I said, well, I can turn the volume down, but I'm also listening to the sync and also listening for conflicts, if there was congestion, hidden transmitter type stuff. So, I mean, all manner of things. I mean, you really have to just get dirty with the data and understand its pedigree. The key point is with you can be an armchair analyst, data scientist, but if you don't understand the pedigree of the data that you have in front of you, then you're in trouble. Let me give you an example. I ran an experiment with field operations once. We had a bunch of drop downs and people wanted 11 drop down items. So I said, gee, I wonder what happens if we change the order of the drop downs. Will the reports, the nature of the problems change? Sure enough, by changing the first 4 items on a drop down to be something else, now it started to shift the kinds of outage reports, because people were just picking one of the first 4 items on a drop down as a convenience item. So basically, it didn't matter. If number one, if you had too many options, it confused the users. Number one, and number two, they basically you would see a result that would change the data that you're actually getting. So basically, the data was worth less than you thought. Another factor is if someone says we need to have fewer of these kinds of outage reports, the answer is people will stop reporting those kinds of outages. They'll report them as something else. Instead of no trouble found, they'll be the class called came clear. And that kind of thing. I mean, I watched it happen. It's human nature. I mean, so there's a anthropological element to our art.
We have a question. Are we too concerned with getting lots of data and video to commanders in warfighting or public safety? Doesn't this overload decision making? And what happens when you can't deliver all that data because the network suffers failures?
Well, when networks suffer failure, and people are in harm's way, people get dead, or the mission fails in some way, or becomes unnecessary. In military terms, they call that friction, right? So the question is it too much? It depends on the discretion. I mean, in a warfighter environment, we delegate a lot of authority through standing rules and commander's intent down to the lowest echelon, literally to a lowly private, I mean, we delegate a lot right down the food chain. In law enforcement, we don't do that as much. And it really depends on the operational rules for a law enforcement agency or any public safety agency, whether it's firefighting, EMS, emergency, other kinds of emergency response other than law enforcement. I mean, so yes, you can overdo it, but nothing. I will say this: pictures are worth 1,000 words. I mean, they do help.
Question here about, do you have any comment on the emerging integration of 5G and satellite in the context of resiliency and emergency comms?
Yeah, I have 2 thoughts on that. One is I think it's a wonderful thing. I mean, you saw probably in the last week or so, John Stankey and he, among others, among executives across the cellular wireless industry, have talked about filling in their gaps with satellite platforms, and also wireless, fixed wireless interfaces. So I think that those are very, very wise and useful things, because they will provide a level of resilience. Now, having said that, we had 2 hurricanes roll through here, which is why my ham shack is, not finished in its remodeling, because outside looks now neat and orderly, but it's got a lot of carnage from 2 hurricanes rolling through here in one season, including one in excess of 170 miles an hour, by the way. The house is fine, amazingly enough, but my ham shack not the ham shack, but the antennas took a beating. Anyway, if you look at the situation, one of my, I don't want to say which one of my cellular providers was not able to, offer their fixed wireless service after the storm. Another one was, I'll say that. And so, so a satellite option such as Starlink would have been lovely, or one of the other competitors as they emerge. Any of those would be a great improvement on resilience and be helpful. Our fiber actually stayed up even after the power went down. All I had to do was provide power to my ONT and my router, and I was back up. That's until several trees took down 1.5 miles of fiber. But so I mean, all of these things have their limitations, right? The cell sites limitations were that they didn't have connectivity to their cell sites. So in one carrier's instance, I don't want to say who, but the other one did. So we were able to throw a cellular router on the front porch and use the Wi-Fi in the living room and the dining room. So we were good. We never lost internet. We just had to layer in options.
Gordon, you've been successful in getting your scouts interested in STEM stuff. How do we continue to do this so that we can fill the ranks of the engineers and techs we need in the future?
Okay, so STEM is an interesting and very provocative term. We give that to less than 5% of our students. And of that 5%, very few of them become engineers, just by definition. They're academically gifted people, and that is a wonderful thing. But it's a numbers game. Some become doctors, some become lawyers, some become businessmen, some become something totally different. Their avocation, their interests are somewhere else. But they were good STEM students, so they got picked for the STEM program. The problem is we need STEM at the 50th percentile. That's the problem, and down to at least that. Because at every level of the workforce, I need somebody who can turn a virtual wrench, and have an appreciation for wireless. That's consistent with their understanding, of the technology. So how do you do it? You make it fun. So I'll give you an example of a game I used to play. We had a bunch of Linksys, pizza box, bless you, John, pizza box routers that we had broadband hamnet soft mesh code in there. So they're only 27 milliwatts. They didn't talk very far, but we would scatter them around. We would take very precise measurements as to where they were, and we would ask the kids to go use Wi-Fi Analyzer, the application that's on Android Android platforms, and go find these nodes. Now, how did they do that? Well, the first thing they had to do was they had to build out of sticks. They had to make a poor man's parabola out of sticks, and then line it with foil, and put the phone out there in front of it, secure the phone, and then walk around and try to find the node. When they got there, they had to they were given a medical problem to solve. They were given a handy talkie on FRS or on MURS to report back the problem and to provide the location information for where they were, and so they go from hop to hop to hop, and they had to write down the MAC address. So they learned all sorts of things. They learned geolocation, they learned map skills, they learned knots and lashings, they learned, a bit about radio direction finding, and on and on and on. And they learned how to communicate. They learned communications protocols, how to report something in a formal way, a tactical communication. So it wasn't one thing. It was a bunch of things that they learned all at once, but they built on essential building blocks. And you could take a group of, let's say, 2 or 4 scouts of varying levels of skill, and they'd all learn together. And some may be more experienced than others, but they would lift all, they lift all boats, as it were. Everybody would come back smarter.
I find that amazing that you had the wherewithal to come up with those ideas. I was almost going to ask, have you ever written a book about ideas for kids to like these projects you just talked about? But obviously that's you're good at doing things like that, clearly. There's a question. How do you manage to encourage others to continue to be ham operators when there are so many resistance nowadays for people to use cell phones or other modes of communication?
Gordon, I think you froze.
Yeah.
I think he's frozen. Guess we got an internet problem. Okay, we'll give it 30
Let me try
seconds.
turning off my video.
There.
I just turned off my video. Is that better?
Yeah.
Yes.
Yeah, I
hear you
just
now.
turned off my video. Yeah. So Barney, I got most of what you said. So yeah, there's a natural resistance to trying other things, but if you make it something that they can learn multiple skills and apply multiple skills and have some fun, doing it, then it becomes much more attractive.
Obviously.
I'm going to try turning the video back on. We'll see how that works.
Barney, I think we got one more question, right?
Oh,
Sure.
Yeah, there's one that just popped up. Any idea how us techies can bring our experience into schools? Or if not into schools, find a place to attract students outside of the present education structure? Have you found more interest at the middle or high school level?
I have found that community groups are easier to work with, ones that naturally work with children. Schools are very resistant because they have their own, shall we say, barriers. Number one, they're concerned about the kids' safety. Number two, they're worried about who are these outside people. So I'll give you an example. I used to teach 3rd grade through 8th grade arithmetic using a 4-foot solid parabola, and the geometry of a parabola. And if you think about it, calculating the focal point is relatively simple. It's 2 and 3 digit multiplication and division. That's all it is. So if you don't say the diameter squared and say diameter times diameter instead, you all of a sudden can grab onto a 3rd through 8th grader and have them understand that. But what we did was we set it up at face height on a tripod with a slider, and we would alternate putting it in all the way and all the way out, and tell the kids put the end of the slider on their cheekbone and say the word hello into the dish. And I said, look, understand, your mouth is here, your ear is here, so neither is ever going to be in the focal point perfectly, but I just want you to know, maximize where the acoustic focal point, where it's loudest. And so we would do that. We'd take some measurements, we'd write them down, and then what we would do is we'd average them, and then we would find out. Then I'd show them the actual calculation, and they would say, well, what the rote calculation is versus the data they collected. They were like, oh, we were pretty close. And then for the older grades, I would throw out the top 20% and the bottom 20%, and they learn about statistics. So we'd throw that in there. So throw out the outliers, and they'd be even closer. And so that taught them a lesson too. So, it was fun. The other thing I did for the teachers, I kept separate logs for the boys and the girls, and by name. And that way they could also tell whether or not kids were risk takers or not. By the way, boys are more risk takers, just statistically. It's the Y chromosome. And the girls are much better at doing the job. Don't get me wrong, but the boys will be more, as long as they weren't showboating for the rest of the class. they basically were more risky. They would try different things, um, and come about things a bit more indirectly, whereas the girls were very precise. I mean, it's just the nature of the beast. And I did this for 15 years, so I mean, I watched this over and over and over. I mean, and by the way, there are also cultural backgrounds. So we had a lot of immigrant children from different parts of the world, and that made a difference. And the teachers use that as a way to get insights as to how to better reach their kids. But my kids were in a private school, so I could do that. Anyway.
Why don't we do
Good
one more
question.
question and then we're going to close. Barney,
I have one here that someone made a question about, but I'll bring it up. Gordon, what are your thoughts about all the drones flying on the New Jersey skies? The fact that these are not drone toys reminds me of when China was allowed to send a spy drone across the country from Alaska to Virginia before it was shot down. How is this possible when I cannot even fly my own drone illegally without consequences?
Yeah, so actually, that's my old home turf, so I know this area very well. There are four options here. The government's doing surveillance or practicing to provide, air cap surveillance and ground cap surveillance over Mr. Trump's estate and also over Picatinny Arsenal and related facilities. That's number one. Number two, you have a foreign or a non-state actor, who knows, flying some of these things over these things, and we're probing them, they're probing us. Who knows? And then a third is a meathead or a set of meatheads, just being, and the fourth is hobbyists who forgot the rules. So all of these things could be possible, and they're not in any way, they're not mutually exclusive in any way. My personal feeling is I'm thinking that they're probably security, government security, apparatus in effect. I mean, it's pretty straightforward. I mean, if this administration or any administration allows non-state actors or state actors to fly drones over us, for a foreseeable future, especially after the balloon incidents, I just don't think that's politically tenable. I mean, there'll be hell to pay if that happens. So God willing, I would like to believe that it's the odd meathead and interspersed with largely government doing their job.
okay. Thank you.
That's been a pleasure.
Yes, Gordon, this has been a great interview. I think we got some interesting questions from the audience. Barney, thank you for the help. I will say that the next interview is written down, but Tuesday, March 11th. So it's always the second Tuesday every 3 months. And the audience might be interested to know that I've already got speakers lined up for the next 3 interviews. I've got one CEO, one former general manager, and I've got 2 wireless researchers who have stumbled upon some very interesting things. So you look forward to that. The wireless researchers rather, I believe will be in March. So everybody have a happy holiday. Enjoy your time with your family and friends. Have a happy new year in 2025. And remember that the Radio Club is there for you. If you're not a member, please consider joining because we are a group of wireless professionals. Never mind that we've been around since 1909. We do fun stuff, interesting stuff, and Gordon was a good example of that today. Thank you very much. Good night.
Thank you again for this opportunity.